side there. Okay, so here's your worksheet, Math 9, on area of shapes. So we have triangles, rectangles, squares, circles, okay, on this first page. So I am going to do with you the first column on the left. Now, what I want you to do, there's not a whole lot of room, but I do want you to show your work for these, okay? I do not want just the number answer. I want you to show your work, what numbers you put where. So, for this one, this is the kind of the base work that I need. Area for a square is going to be what? This is a square because all of these little tick marks are the same on all the sides, and they're all 90 degrees, so that makes it a square. So we have area is 11 squared. You don't need to put the formula, although you can put the formula first. 11 squared, the area is 121. Please make sure you put the proper units. Feet, that's FT is feet, squared. Okay? All right. Any questions there? Number 4, the area for a circle is pi r squared. So area equals pi times, now is this the radius or the diameter or something different? What's that one for 4? That's the radius. So it's just going to be 8 squared. So the area is, 8 squared is 64 pi. Okay? Now, okay, so I'm going to adjust this right here. Remember we talked yesterday about using 3.14? Don't use 3.14. Okay? We're going to change this. You're going to use your pi button on your calculator, or do you remember the number that I suggested you use if you don't have a pi button on your calculator? 3.14. What are the next three? 159. Thank you. Please go a little bit more deep, a little bit more detail there. 3.14, 159. That one I think you can remember. Easiest to use your pi button, and certainly you probably should use decimals, so you will have to use your calculator. So put your answer in decimal form when possible. So 64 pi is equal to 201.06. 201.06. And that's going to be, what's YD? Yards, that's correct. Yards squared. Square yards. Area is always squared units. Excellent. So remember, grade 9s, that this answer right here, 64 pi, is actually the most precise answer that you could give. Pi includes all of the infinite number of decimal places in pi. So that's actually a very accurate answer. But you're going to be dealing in grade 9 mostly with decimal answers. So put it into your calculator, round to 2 decimal places. You'll be safe. But you guys know that this actually is a very exact answer as well. Okay. Rectangle. So the area is going to be 2 times 12. This is super easy. It's almost too easy. Area is what? 24. And what's IN? What's that symbol for? Inches, yeah. So square inches, or inches squared. And let's do a triangle one. So the area of a triangle is 1/2 base times height. So the area is going to be 1/2 of, well, 7's on the bottom there. This is a right triangle, so that means that this could be the height then if 7's the base. So let's do 7 times 14. So what's that? 7 times 14. 70, 98. Divided by 2 is 49. And the units, feet squared. Okay? You guys agree with that? All right. All right, so go ahead, and your job is to do the rest of this worksheet here. When you get into page 2, again, more rectangles, triangles, circles, and squares. Please make sure you're showing your work for that, which numbers you're multiplying to get your answer. Make sure you have the units, proper units and everything there. decimals to 2 decimal places. So I will look ahead, and on page 3 here, we have parallelograms, and we have on page 4, we have trapezoids. So let's talk about the areas for trapezoids and parallelograms. Okay, so if we go back to your formula sheet, you might want to add this. I've just got area for a trapezoid. And a trapezoid, of course, is a shape where you have two sides that are parallel. And usually in math, we signify two lines being parallel by putting an arrow in the middle of the lines, like that. And so two sides are parallel. The other two sides are not parallel. Okay? So it's different than a parallelogram where all four sides are parallel. And it's different than a rectangle where opposite sides are always parallel too, and they meet at 90 degrees always. So a trapezoid, sides do not have to meet at 90 degrees. Two opposite sides have to be parallel, that's it. So a four-sided figure, two sides, opposite sides are parallel, and that's it. So if the one side is A, that's the length of one of the parallel sides, and the other length of the other parallel side is B here, okay? So A is one side, B is the other side parallel. Then the area formula looks like this. Area of a trapezoid is the average of A and B. So how we find that is A plus B over 2. So we want to find the average length between these two. And then we multiply by the height. So A plus B over 2 times height. So it's kind of like length times width in a sense, where the length is the average of those two parallel sides. Now, I don't want to get too far into it, but that's, I think, fairly reasonable if you think about this. The average of A and B is going to be about here, this length right here, because here's A, the little side, here's B, the big side. So the average is going to be about here. And if you take that and you multiply it by the height, you're finding the area of a rectangle like this. So this rectangle, you take this piece and you put it in there, and you take this piece and fit it in there as well, and then you've got an equivalent area. So you take the average of A and B multiplied by height, and you're making, that maybe rectangle is a little bit small, but you're making a rectangle that has the same area by taking the average of A and B. Okay, what else? Oh, any questions about that?
Can you do number like on the last page, number 2?
Yeah, just give me a second here. Let's go over the area for a parallelogram. So a parallelogram, that picture is of course where we have two pairs of parallel lines. So it's like a rectangle that's been tipped over a little bit. And this is how we would signify pairs of parallel lines. The single arrow here and the single arrow over here means those are parallel. And then double arrow and double arrow, that would signify that these two, top and bottom, are parallel. And really, this one is really easy to understand as well, because you have a height and you have one of the sides there, and you just multiply really the length times the height. So the length and the height, because you're making a rectangle where this little triangle piece right here just fits perfectly in this spot right here. So you're moving it away from here and over here, so it's just like the same as a rectangle. So the parallelogram is still just length times width. Or we could say length times height if you want. But it's the same as length times width. So one of the side lengths times the height, of course that would be the distance to the other side of the parallelogram that makes a 90-degree. Or base times height if you want. Base times height is fine as well. Okay? But the length and the height have to make a 90-degree to each other. That's the only requirement. Okay? So let me do a couple with these new, where do I have to go here? So we've got trapezoid on the 4th page, and we've got parallelogram on the 3rd page. So let's do parallelograms because they're really easy. It's really just like it's a rectangle. So here's a parallelogram number 1, And again, if I treat this as a rectangle, check this out. You see, if I treat it as a rectangle, I can literally pull this space that's outside of the rectangle and I can put it right here to fill in this space, and it becomes the exact same as a rectangle. So that's why you can just do base, and here's the base that's given, times height. So the area is 16 times 4, and that's going to be for 64. That's going to be 64 feet squared. Okay? The base times height. There's another parallelogram over here. Base 11 times height 5. Really easy. Another parallelogram, number 11, simply 7 times 18. Really easy. Let's do a trapezoid one here. I'll show you how to do a trapezoid. Okay, so last page, number 2. If you want to just skip there, let's do this one together. So the last page here at number 2, that's a trapezoid, because this side and this side are parallel to each other, and the other two sides are not. So that's called a trapezoid. So this one is not, it's kind of tipped sideways, right? So A and B would be, again, the lengths of the two sides that are parallel. So this is A and B. So the area here, I'll just do it up here, would be 3 plus 11. Don't multiply them, but you have to add them. 3 plus 11 divided by 2. So we're technically finding the average of those two sides, and we're multiplying it by the height, and that would be the distance connecting those two sides, okay, forming a 90 degree. So times 7. So that is 3 and 11 is 14 divided by 2 is 7 times 7. So 14 divided by 2 is 7 times 7 is going to be 49. I heard that over there. Good. 49 square yards, or yards squared. All right. So that's probably the trickiest one you're going to find, but that shouldn't be too bad. Let me just talk about another trapezoid. So obviously the base, right? Or this is B, this is A. So you find the average of 6 and 2. That's 6 plus 2 divided by 2. That's 8 divided by 2 is 4 times 14. That's going to be your area, okay? Down here for number 10, 4 plus 20 divided by 2 times 1. All right, any questions so far in these worksheets? Before I'm done, I'll give you some selected answers so you can double check how you're doing with these numbers. So I've given you a few questions here from page 1. Those are the answers for those ones, and then I'll give you some answers from page 2 here as well. So page 2, some selected answers. Number 1, 11 times 17 is 187 square inches. Number 4, the area of this square would be just 8 squared, which is 64 yards squared. Number 7, this is a circle question, so it's pi r squared. So that's 4, which is the square of 2, 4 pi. In decimal form, that would be 12.57. Please round this correctly. This is 6, I believe. So that's 6 because there's a 6 behind it on your calculator screen. Should go up to 7. And finally, there's a triangle one I'll do at the end for you, just to remind you. 1/2 base times height, 1/2 9 times 12. And you could do 1/2 of 12, which is the easy one to do in your head. That's 6 times 9 is 54. So 54 square feet. Some selected answers from page 2. All right, some selected answers for page 3. Number 1, 64 feet squared. Number 7, remember it's pi r squared for the area of a circle. So that's 4 pi, similar to the one we did in the previous page, just different unit. So 12.57. Here's, I did a parallelogram and a rectangle for you just to see that this parallelogram here, you find area the exact same way. It's base times height, same as this. Length times width would be the same as base times height, you see? And I kind of like how they show the height here with this dotted line, because if you just cut that triangle off and you move it over here, You see, that makes a perfect rectangle. That's why you can just do length times width, because this is 7 here, and that's 18. So it's the exact same area as a perfect rectangle there. So I'll just give you this number 2 on the last page. Again, the area of trapezoids may be the trickiest. Average the 2 parallel side lengths, and then multiply it by the height. You only need to pick 6 from this one for this assignment I'm giving you today. So I won't give you too many answers here today. I'll be interested to see how you do that on your own when you hand that in. Okay, any other questions about this? Please make sure you show your work like I do. Okay, show where you're putting your numbers in the formula at least. You don't have to write out the formula every time, but show where you're putting the numbers inside the formula and do some simplification that leads to your answer. I do not want to see just number answers here. You need to start showing your work. And again, that's something you need to start working on in high school, because showing your work in grades 10, 11, and 12 are the only way that you're going to succeed. Okay, working through that, learning the process and getting used to kind of writing down each step, okay? So you gotta trust me on that one. So we'll start to practice showing our work here with these kind of things, okay?